We have a block of lightning talks starting now, and Tyler is going to kick us off with a talk about how Uber manages Go dependencies with Bzlmod.
Hello. My name is Tyler. I work on Uber's Go developer experience team based out of New York. And today I'm going to talk about Bzlmod and more specifically Go and how Uber migrated to Go with Bzlmod. So first, I want to dive a little more into the Go Bzlmod experience, how it was created and why it was created in such a way. So let's first take a look at how Go modules work. The Go modules ecosystem works using a go.mod file, which declares all of the dependencies needed to build all of the packages within that module. There's also a go.sum file, which has all of the integrity values to make sure that the downloads are correct. So with Gazelle, what we do in the workspace dependency system is we create these things called Go repository rules. And Go repository rules take the sum from the go.sum file, they take the version from the go.mod file, and they're generated with a command called Gazelle update repos. Now let's talk a little bit about the pains of Go repository rules. Go repository rules get really messy because they create really large files. Go repository rules are required to declare every single transitive repository needed to download, whereas the go.mod file doesn't need to do that. So now we have files that are like 20,000 lines long declaring these Go repository rules. They duplicate the information from the go.mod file, and then you have to keep them sync manually using Gazelle update repos. So let's now look at how Go modules works. So Go modules uses minimum version selection. This is done without a lock file because minimum version selection is deterministic, so there's no need to check this in. But there is the Go sum for integrity purposes. And then the root module file, the root Go mod file, is allowed to declare overrides. So it can replace certain versions and it can exclude certain versions. This looks a little bit similar, right? And yes, it's very similar to the way Bzlmod is designed. Bzlmod declares the direct dependencies. It then does version resolution using minimum version selection. It has no lock file, although now you can optionally include a lock file. And you can provide overrides, but these overrides are only usable in the root module. So we take a look at this Bzlmod API. There's a direct dependency you declare with Bazel dep, and then there's the set of overrides. So we designed Go with Bzlmod to follow a very similar API. We declare go.deps.module, which is a direct dependency. And then we provide 3 different overrides. They each do different things. One of them declares, Gazelle declares different directives you can create build files with. And then module applies patches. Archive can be used to download from a different resource. So this is great and all, but we still have to create a module for every direct dependency we use, which is inefficient. So we can use the go.mod file as a source of truth. And so we created this tag from file, which allows us to read a Go mod file and generate the repos from this file. I heard PagerDuty, that's scary. And this allows us to deduplicate all that information from the go.mod file. We don't have to check in the versions in Go repository rules. We now have a much more simple way. We don't need to have all our sums in the module.bazel file. These are now loaded from the go.sum file. So we can rely on Go mod tidy also for version resolution, and we don't have to recopy over things using Gazelle update repos. So it's a big improvement here. One problem is we still have to use repo for every single direct dependency we use. This is just a drawback of how Go repositories work. We don't know what labels are in there when we first load it, so we will have to use this for a little bit. But overall, this looks a lot cleaner. We declare our go.mod file, whatever patches we want, and then we, in the future, can run a Bzlmod tidy, which will clean up our use repo commands this should be here in 7 or 7.1. Cool, now let's talk about migration. There's a ghost because it's October and migrations are scary. And at Uber scale, migrations include over 1,000 direct Go dependencies. So there's a certain level of automation that we require if we want to migrate to Bzlmod. Additionally, we need some sort of structure and organization because we have a really large repo. So teams need to be able to read and understand how to make modifications to dependencies without involving us every time. And similarly, not one team can't own every single dependency. So different teams, like the software networking team, need to be able to own their dependencies that they specifically depend on. So we need to support dependency ownership. Cool. So first design decision is, what do you do for an internal registry? First option is you depend only on the BCR. And this means that you rely on every module that's in the BCR only, and if you have any internal modules, let's say you have an internal rule set, you need to use internal overrides to do this. You can use the URL rewriter for mirrors, so you don't have to worry about integrity or availability of github.com, but we still have to depend on the BCR. So the next option is a partially internal registry. This is where you have your internal rule sets or things that you depend on internally that are versioned in your internal registry, but then you still depend on the BCR for all of the open source stuff like Rules Go and Rules Python. And this is a good option, but you still depend on the availability of the BCR host. So next is a completely internal version. This is where all of your modules that you depend on, you download and copy into a registry somewhere. And this just adds a lot of tooling, but it means you're isolated from BCR outages, which is good overall to be isolated. So initially, this was our plan. We start short term here, and we move to long term with a completely internal registry. But a good solution presented itself is that we can move from a partially internal to a completely internal registry almost by using a proxy caching layer. So we can use Artifactory's BCS repositories or something similar where we send a request to Artifactory. If it doesn't have it, it sends a request to BCR, caches it with some TTL. And now we don't depend on BCR and we eliminate the tooling. So that's our solution. So another design decision we looked at is, what repository rules do we want to use in module.bazel and which ones are a little inconvenient to use? So here's an example of an extension that we would use to load some HTTP files, for example, maybe some test data or some images. It's a little toilsome. You have to add a use repo call, and you have to add the artifact to an HTTP archive. So we decided to not use Bzlmod for these dependencies. The rationale here is it's much simpler user experience. We don't want users to have to modify the core module.bazel file when they're adding a new repo. And we want to be able to keep this experience the same as it was, where you can put it in your team's directory and load the file. This is a little bit alleviated with use repo rule, but similarly, it's in the root module.bazel file. So we still have to be maintaining the organization there. Next, I want to talk about dependency ownership. This is an internal design we have where we place our Go repository rules in different directories based on their ownership. And this allows a team to own a certain repository rule. And then we have a metadata for each directory that applies reviewer permissions for that directory. I'm sure companies have other similar things. And so when someone modifies that repository rule, it requires a certain team's review. But this is not possible with the module.bazel because everything's in one file. So we need to find a new solution here. Currently, we're looking into dynamically assigning reviewers based on reading the changes and analyzing them to the module.bazel file, but that's a lot of tooling, and we'd rather just use directory structure. So what's missing? Overall, right now with Go, we've noticed that overrides are getting messy. If we have to apply 100 to 200 different overrides, that's not scalable. So if we can group a set of overrides, apply one directive to all of them, or even apply blanketed overrides to every dependency, that would be much more user-friendly. Additionally, we want to better structure our overrides. And this is similar to talking about module.bazel management, but even if we could load our overrides from a file, this might make things more organized and separate things out better. Additionally, module.bazel management is going to become a pain point. Ours is about 2,000 lines long right now, and it's only going to get longer. So if we have a way to structure it, organize it, so that any user knows how to make changes to it, and we don't have to apply a central review to these changes, that could scale much better. So these are things to think about. If you have any ideas for things that are missing, please file an issue either on Rules Go, Gazelle, or I guess Bazel. This is a very growing and in development area. So there's a lot of changes being made, and there's a lot of attention happening right now. So definitely please send your issues in. Yep, I wanted to give a special thanks to Jean Peng and Fabian. They've done a lot of incredible work on these rule sets, so that's great. I didn't think I'd have time for questions, but it looks like I'm a little under time, so I don't have, okay, never mind. Okay, Slack me, say hi. I guess that clocks. But thank you. I appreciate it.